Well, hello everyone, and thank you for coming to my session. I know I'm sort of the thing between you and an ice cold beer, so I appreciate you actually coming to my session. This is the introduction to VMware NSX, so I'll be going over what NSX is and how it's different and some of the things that some of our customers are doing with the product. One of the things I like to do, just for my edification, is get people to raise their hand. It's hard for me to see with the lights, but get people to raise their hand. How many of you are virtualization guys? Classify yourself that way, right? Okay, how many are networking guys? Okay, some, good. Security guys. All right, good. This is really interesting and great for me. I was here 4 years ago when Nicira had just been acquired by VMware, and I think I had a room maybe 1/4 of the size, and a bunch of people had no idea what NSX was, and now we're filling up rooms of hundreds and hundreds of people. There are networking people coming to VMworlds, so this has really been changing over time. You know, I'm a networking guy from way back. When I started in networking, it was big, thick yellow cables and vampire taps that you had to sort of wrangle like an anaconda to get into the walls and so forth. So very big changes that have happened in networking over time, and this is a really exciting time to be part of networking, whether from the virtualization side or from the networking side. So hopefully I'll give you guys an understanding of what we're doing here, and everybody leaves kind of with an aha experience about what it is NSX is. So the first slide, of course, I think it says something about me being a marketing guy, therefore you can't believe anything I say, but you know, forward-looking statements, so forth. So we're going to talk about going beyond server virtualization. All of you are familiar with what we've done in server virtualization and how that's changed the operational model of the server. Now we're virtualizing the network, and this is transforming every industry out there. I want to show one slide very quickly that shows a bunch of our customers. Now we have I think over 1,000 customers, probably a couple hundred of them that are in full production mode. This is just a sampling of some of them that you might recognize here. We've got very large customers like NTT and AT&T, people like eBay. eBay has 60,000 VMs running on thousands of virtual networks running on top of NSX. Our first customers were big service providers who wanted the speed and agility to be able to deliver the services that they deliver in the network, but do that in a more software-defined way, right? So those were our first customers. And then we moved into global financials. So you see people up here like Citibank and JP Morgan Chase and Goldman Sachs and HSBC and ING. These are all companies that are using NSX. Right? It moved in from the global financials down into, you know, more general enterprise customers like Starbucks and Columbia Sportswear and DirecTV and others, right? That a lot of the use cases they started seeing weren't as much the speed and agility, although that became very interesting for them. It was security. And so the security that's delivered by this new kind of infrastructure became a very attractive initial use case. But even as those companies got attracted by the security use case, they started finding out what you could do from a speed and agility standpoint in the network, and they very quickly moved to that use case as well. And as you'll see as I go through here, there are many use cases of NSX, and it just depends on what's most important for you as to how you will justify NSX being put in. One thing well, let me go back, because there's one thing I want to mention here, because there's something in the media. The media, if you read the magazines, you read the articles and so forth, it sounds like there's a big fight between VMware and Cisco, right? The reality is the media loves a fight. They love writing about a fight. They love creating a fight, right? This is what gets readers to read things. The reality is, we love Cisco. A lot more than Cisco loves us, but we love Cisco because about 85% of all of our deployments are running on top of Cisco gear, right? As you'll see as I go through the presentation, what we require from the underlying physical network is that it forwards IP packets, right? We don't care what it is. So it can be old Cisco gear, it can be new Cisco gear, it can be Arista or Brocade or Juniper, white box networking, doesn't matter to us. So from that standpoint, don't let this belief that you're making a decision of NSX or Cisco. You certainly can do NSX on top of whatever Cisco infrastructure that you have, and we love Cisco. So I just wanted to make that point early in the conversation so that's not stuck in your head. So lots of different reasons that is being driven. You all are experiencing these kinds of things in your data center, and it's now really time for a new approach, a new way of doing some of the things that all of us have been doing for 20 years in terms of the way networks are configured and managed today. And that new approach is the ability to virtualize the whole data center construct. Not just the server and getting the benefits that we got out of server virtualization, but now applying this across the data center so that we can become more agile and more efficient and more secure. And to do that, network virtualization is a key to making all of that happen. It's the thing that we have not had in the past. So one of the things I want to do is define a software-defined data center, because there's a lot of definitions that go around. Sometimes you'll hear software-defined data center from VMware being like a packaged product that you buy, the software-defined data center. The reality is this is more of an approach than a product. And it's also not SDN. A lot of you hear and read about SDN. SDN is next generation network management, right? Every hardware vendor you talk to has an SDN approach. It's software that talks to their hardware, software-defined networking, right? What we're doing is network virtualization, where in the past you've had services that run in the hardware, dedicated vendor-specific infrastructure, and lots of manual configuration and management. What we're doing is moving those services into software, distributing those services in software, making it so that we can have the operational model of a VM for the entire data center construct, leveraging a lot of automated configuration and management. So what's left in the physical infrastructure? Because it doesn't go away, right? I mean, we're not just running on air. Packets need to flow across physical switches and wires and everything that's in the network. But this becomes, the physical infrastructure becomes a pool of compute and storage capacity that now in software can be provisioned and repurposed on demand. In a much more flexible way, it becomes vendor independent, right? It becomes best price performance, whatever you want to in your physical infrastructure in this pool of capacity. And it actually becomes very much more simplified because you're not reconfiguring the underlying infrastructure anymore. It's providing services to what's running in software. So if we look at most of your data centers today, the traditional enterprise data center, what you have is the applications, and those applications are bound to these services that are configured and managed in hardware. Things like isolation and switching and routing, firewalling, load balancing. All of these are processes that you all go through in terms of configuring those services when you build out an application environment, right? But if you look at the biggest data centers in the world, the most efficient, the most agile data centers in the world, what they've done is they've moved those services into software, in their custom applications in their data center. And what this has done is it's created an abstraction layer between their applications and the underlying infrastructure. So they can choose any compute, any storage, any networking they want. And it gives them the agility and speed and software capability at the software layer, and it simplifies, makes more stable, more reliable, and lower cost the underlying infrastructure. Now, this is great, but not most of you can do this. For one thing, you don't have an army of engineers that are developing all those services to put in your applications. And two, you don't have control of all the applications. You're buying applications. You can't just add services to the applications. So what VMware has done is moved those same services into the data center virtualization layer, into the hypervisor. So now those services are provided to the application without having to modify the application. But you now still get the same abstraction layer that people like Google and Facebook and Amazon take advantage of to get the agility, speed, security, and capabilities that they have. And now you can do that on top of any compute, any storage, any networking. So what this does is it gives us the ability to create the operational model of a VM for the entire data center. Right? So now, where I used to just spin up programmatically a VM and snapshot it and move it and delete it and restore it, now I can do that for an entire data center construct. So this is kind of the strategic thing that's happening. The reason that people are moving to NSX is the ability to do this, to spin up an entire environment in 45 seconds, as opposed to 3 weeks or a month. And I'm going to talk to you a little bit about how that works. So if most of you are like a lot of the customers I talk to, you're here at an introduction to NSX, right? You're thinking, well, it sounds good, but it sounds like a very big change. And I'm not even sure what network virtualization is, and it kind of sounds scary, right? And if you're a networking guy, you're sitting there going, what the heck are they talking about, right? So what we want to do is we want to talk about moving from the traditional approach where you are into this more software-defined data center approach. So first, let's start with the infrastructure that you already have in place. Every one of you has compute, storage, and networking capability connecting those things together. And as I said, this network could be any network. It needs to forward IP packets. Does anybody have a network in their data center that does not forward IP packets? Okay, so we're good there. So, any network there. If you're at this conference, your virtualization layer is likely vSphere. So vSphere becomes the distributed platform that we allow these services to ride on top of and allow you to create what you can think of as a network hypervisor. So just like a server hypervisor gave you the ability to create a software container that represented the x86 environment so that an operating system and an application could run in this software container, but you could programmatically create it and move it and delete it and restore it and do all kinds of really cool stuff. What we do is give you the ability to create a software container called a virtual network that represents the network environment. So layer 2 switching, layer 3 routing, firewalling, load balancing, QoS, ACLs, everything that a connected workload expects from the network, but now in a software container that I can programmatically create, snapshot, move, delete, restore, everything that I do with a VM, but now for that entire construct. And I can create thousands of these logical environments that are completely isolated from each other. Now, it's very difficult to draw in a picture, so when I draw it like this, it looks like these things are all clustered right together in that part of the data center. The reality is these are logical constructs. So the workloads that are built into that isolated logical construct could be anywhere in the data center. They could be across multiple data centers and still be in this logical container that can be moved, that can be snapshot, that can be deleted, that can be restored, and I can apply rule sets to that entire construct and have it operate as an independent construct from everything else. Now, a lot of networking guys will look at this and say, that seems pretty cool, but in order to do this, you have to be able to talk to that underlying infrastructure. You have to be able to create VLANs. and do ACLs and do firewall rules and do all of the things that we do all day long in the data center today for the network. The reality is we don't. And the way to think about that is think about a physical network chassis. You've got sheet metal box with a backplane and line cards that plug into the backplane. Nobody goes and configures VLANs or ACLs or firewall rules on the backplane. The backplane's job is to simply move packets from one line card to another line card as fast as possible. All of the intelligence about what to do with that packet, all the services are actually running on the line card. So I decide if I'm going to drop the packet or route it or do whatever I'm going to do with it, right? So now if you think about those services being moved into each one of the hypervisors, and the hypervisor becoming like a line card plugged into a very large IP backplane, that's essentially what we're doing. So now the underlying physical infrastructure's job is to simply move packets as fast as possible from any hypervisor to any other hypervisor, right? Because the intelligence about what to do with that packet is now running in the vSwitch as part of the hypervisor. Now what that does is it simplifies the underlying physical infrastructure, because now I'm not reconfiguring it to add a VLAN or put in an ACL or change the firewall rules or doing all the things that breaks the network a lot of times. I mean, 70% of the troubleshooting that goes on in data centers today isn't because a Cisco switch catches on fire. Most of them don't, right? It's because somebody fat fingers a configuration file and now it breaks connectivity and I got to figure out where. So when you stop doing that configuration, you get rid of a lot of the problems that are happening that you're troubleshooting today. A lot of that now the problems, but all of that automated configuration goes into software, and I can screw up one logical network and it has absolutely no effect on any of the other logical networks. So the way we do this is we move these services, right, into the hypervisor. So things like routing and load balancing and switching and firewall get moved into the hypervisor. Now, a big point I want to make here is don't think about these services as if that's a virtual firewall and a virtual router and a virtual load balancer, because that's not what it is. It's not a service running as a VM. This is a distributed system where the function of firewalling is now distributed across all the hypervisors, right? It's like one big giant firewall. And I can do about 20 gigabits of firewalling capacity per hypervisor. So if I have 100 hypervisors, what is that? I don't know, 2 terabytes of firewalling capability managed as one big firewall, but applied at an individual port level all the way across the infrastructure. And this you'll see as I talk about the microsegmentation solution, how we leverage that capability. But we're doing the same thing for routing. We're doing the same thing for load balancing. In the future, we'll do other services like distributed network encryption that will be run in the hypervisor and be able to be applied to the virtual construct. So in the end, let's take a look at what this sort of looks like. This is a quick little video. It's vRealize Automation Center back when it was called vCloud Automation Center. But I clicked on a 3-tier blueprint. See the app tier, the database tier, the web tier. Clicked on the web tier, added 2 machines, hit submit. The engineers give me a really useful screen that says that I hit submit. And then I go to requests. And you see that it's in progress on the top line there. Less than a minute later, it's successful. Okay, so what did that do? That deployed everything that's in this blue box. So this blue box is the software container that I'm talking about. It's 3 layer 2 switches, right? A layer 3 router that connects them together, turning them into layer 3 subnets. I've got 2 workloads on the web tier, 1 on the app tier, 1 on the database tier. All the firewalling rules associated with each one of those VMs so that the web tier can talk to the app tier, but it can't talk directly to the database tier. and the web tier applications workloads can't talk to each other. I'm getting to the outside world, in this case using NAT, but I could be using static routes or BGP dynamic routes, whatever, from the edge of this logical environment in the outside world, and then deployed all of that on top of the existing physical infrastructure without talking to it or reconfiguring it or changing it in any way, right? Now, for most enterprise companies, and think about it for yourself, how long does it take to deliver that? For most enterprise companies, this takes from 3 weeks to a month. When we first went to eBay, it took them 30 days to do this. They had process re-engineered that down to 7 days. And they were very proud of the 7 days because from an industry standard standpoint, that was actually really good. Then we delivered exactly the same thing with exactly the same connectivity and exactly the same security in 45 seconds. So they raised their hand and said, we have one question. Why isn't this in production now? And soon it was, and like I said, now they have 60,000 VMs across thousands of virtual networks all over eBay and PayPal and everywhere, right? So this is what people are doing today in terms of speed and agility of delivering network services. Now, we can do this in a bunch of different ways. I kind of showed you this second column, vRealize automation, end user predefined. But a lot of our customers, in fact, most of our customers, haven't gone even to that stage in terms of self-service provisioning of a system. They're using more of the NSX manager type, or maybe using vRealize automation, but it's about IT automating IT. So that when the request comes in for the new infrastructure, instead of waiting for 3 weeks or a month to get it done, it happens that afternoon. And so this answers the questions of all of those shadow IT, all of that shadow IT that's happening where people say, hey, I can go to Amazon and I can spin up an environment this afternoon. How come IT can't deliver that to me? Well, today, IT is handcuffed. They want to be able to do that, but IT is handcuffed and can't deliver that because of the processes associated with their underlying physical infrastructure. So now you can deliver and give the same sort of business response, the same service delivery that an Amazon or somebody else can deliver, but do it on your own internal infrastructure. And then we go to end user custom capability. We have lots of customers using OpenStack, where actually NSX is actually the underlying logical infrastructure for the largest OpenStack clouds in the world. AT&T, NTT, Rackspace, eBay, Yahoo, all of these guys use NSX as the underlying logical infrastructure on top of all kinds of different physical infrastructures. So let me show you a quick 2-minute video from a company in the US. This is in Chicago, Tribune Media. But it's a really great video and talks about his experience of going to NSX.
With a total of 42 owned or operated broadcast stations across the U.S., Tribune Media has become one of the nation's largest independent broadcasters. And as it continues to transform its content, service, and delivery, data center security has become priority one.
I've lived the world as a CSO, Chief Security Officer. I've also been a CIO, and I've been a CTO. So there's not many things I've gotten excited about where I could have all three hats. When I saw NSX and I went to my team, everybody kind of had their different viewpoints. I'm like, you don't understand. This isn't a step. This is an evolutionary leap in capability around operations, around security. We needed a platform to absorb SaaS applications, and we needed to have a platform that would change the security geometry that there was today. The answer was pretty simple for us. It was VMware with the Hypervisor and NSX. So we set up a pilot, we put NSX in, and the bell went off. We can do this. In 5 months, we moved 141 apps onto the infrastructure, and we had 9 help desk calls. So guess what? It works. With the NSX platform, I can move networks. I can move everything. So if I'm getting attacked, I'm just going to move it. So if I have something on my internal cloud and I want to move it to an external cloud, all of my security moves with it. That's awesome. I'm here to help the business units, and I'm here to keep it secure. But you step back a little and you look at literally where we've gone from the Flintstones to the Jetsons in less than 18 months.
So pretty exciting. I mean, 141 applications in 5 months with 9 help desk calls. You probably get 9 help desk calls a week on the infrastructure today, right? So this is the kind of thing that you can do here. So now let's take a step down. That's kind of the overview of what things are. Let's go a little bit deeper, talk about how some of this works. So you're all very familiar today with having a couple VMs running on a hypervisor, and those 2 VMs need to talk to each other so the packets flow through the vSwitch, right? This is the first stage of virtual networking. There are more workloads connected to virtual ports in all of your data centers than there are physical workloads connected across the world. We crossed that level sometime in 2012 in terms of the number of virtual ports being used versus physical. But if I go and I put one of those VMs on a different subnet, now what happens? The packets flow down, they go out across the physical network, they go across the oversubscribed core in your 3-tier architecture, hit the core router, come back just to talk to the VM that's sitting on next to it. Now, this is increasing more and more. This is what we talk about as east-west traffic. As application design has gone from, to web tier, app tier, database tier, now I see a lot more traffic going east-west than coming in and out of the data center north-south. And every time I have to go from the web tier to the app tier to the database tier, I'm doing this and going out across the core in order to move between those packets. So we'll talk a little bit more about that later. So now let's look at this from a virtual network perspective. Now I'm going to show the virtual network here as a thing, this box that has those routers and switches and so forth in it. But a virtual network isn't a thing. It doesn't exist any one place. It's actually the little green boxes that you see in the hypervisor. So think about those little green boxes as layer 2 service, layer 3 service, firewall service, QoS, ACLs, right? And so when I provision a workload, I apply those services to the workload that I provision. So in this case, I'm saying these 2 workloads are connected to the same logical switch. Therefore, the packets that flow between them are going to do exactly what they do today and use the vSwitch using the layer 2 service, that first green box. But if I now put one of those VMs on another subnet, I'm now needing to route between them. But with virtual networking, what happens is the packet flows through the layer 2 service and the layer 3 service, and with the layer 3 service, it gets routed right there in the virtual switch back to that VM. So it doesn't go out across the network in order to get that routing service from a physical router, right? It only needs to do this. And then if I want to spin up another VM somewhere else in the data center, across multiple subnets and availability zones, even in another data center somewhere, and tell that workload to connect to the same logical switch, it does. And it looks like it's L2 adjacent. It looks like it's running right next to it in the same hypervisor. But now the packets flow across the back plane, if you will, so that I can have this connectivity between these 2 workloads. And I'll talk a little bit more about that as we move forward here. So the way this works is you saw me use vRealize Automation Center as the cloud management platform, but this could be OpenStack or CloudStack or a custom cloud management platform, or just using, Python yourself and writing API calls to the controller. When you provision the VM, you talk a RESTful API to the controller, and the controller pushes down the network services that are associated with that VM. Now, if that VM ever moves, vMotion it over onto another hypervisor, all the little green boxes move with it. So all of its security, all of its networking, everything associated with it, all the policies associated, move with it with no human intervention at all, and no modification to the underlying physical infrastructure. Now, when those 2 VMs talk, what happens is the packets leave the VM, they go through the network services. And let's say, for instance, that third green box is the firewalling service. So based on the policy, if that packet that left the VM needs to be dropped, it gets dropped right there at the virtual interface. It doesn't go across the network and hit some firewall to do this. The policy and the ability to do the enforcement is happening right there in the virtual switch. Once it gets past those services, it then gets encapsulated. Now, don't be scared of encapsulation. Encapsulation only means I'm sticking a header on the packet so that I can fire it across the physical infrastructure to the other hypervisor, and then I take the header off and hand the original packet off. So the packet that left this VM shows up at that VM, right? Now, people like Cisco like to make a big deal about, oh, VXLAN encapsulation, you lose visibility. We have been doing encapsulation for a very long time. MPLS, Lisp, OTV, GRE, IPsec, on and on and on. These are all encapsulation protocols, right? Visibility only became an issue when we had NSX, and Cisco wanted something to talk about, right? So we actually give you better visibility into what's happening in this entire environment than you've ever had before. And I encourage you to go down to the booth and ask somebody to show you vRealize operations, where you can see exactly what the logical network construct looks like and exactly what the physical network construct underneath that logical infrastructure looks like. And you can do trace flow and say, this logical network is going through this specific path in the physical network. We can see both the physical and the logical. And remember that as you move to something like this, you simplify the underlying physical network. You don't change it, therefore you don't break it, therefore you're not troubleshooting it as much. So there's actually some real benefits as you move to this kind of capability. One of the really cool things about network virtualization is the fact that each one of these virtual networks is completely isolated from each other, right? So this blue and green here could be a multi-tenant environment, or this could be my dev and test environment, where you see I have overlapping IP addresses. So I have the same IP address on a blue workload as I have on a green workload, but I can do that across the same physical infrastructure because they're completely isolated from each other. So I can move from dev to test to production like that instead of having to change the IP address and do some interesting things that you have to do today, right? Very powerful capability. And this isolation is really strong isolation. Just to give you an example, the US Army used to go out, and when they would build a remote site, they would create two physical networks, completely air-gapped, one for US forces, one for coalition forces. The problem was, if coalition forces need more compute capacity, they had no access to the US side of things because it was air-gapped. Now what they do is they build one physical infrastructure, one pool of capacity, and they isolate US forces from coalition forces in logical networks, and now either side has capability to get to all of the available capacity that's in the network, storage, and compute. Very powerful capability. So now let me show you another application of it, right? So for DR, how many of you are using SRM, right? Or Veeam, or anything else, right? To do kind of active standby. Today, what happens is you snapshot the VM essentially, put its storage in the VM in the SAN replicates it over to the recovery site. If you have a DR event, you recover the VM. What's the first thing you got to do to that VM? Change its IP address, right? Because now you're sitting on a new physical infrastructure. Unless you're stretching L2 and doing OTV and a bunch of complicated stuff, this is what you're having to do. Now let's look at this with NSX. So now with NSX, I have that VM connected to a logical network. I use exactly the same product or technology that I'm using today to snapshot that VM, to replicate it across in my SAN, but at the same time, I'm maintaining my controller so that any changes that happen in the NSX controller are replicated over in the recovery controller. I may not be using that logical network that's there, but it's already there in the recovery site. So if I have a DR event, I recover that VM, click, there you go, and the network and security that that VM is expecting is already running. So it just connects to that network. You don't change the IP address, you don't change the security, and you can reduce your RTO time by 80%. So pretty cool little use case of NSX. Now, I've talked a lot about virtual machines and connecting virtual machines together, but we also support physical machines, right? So the way we do that is two different ways. One, with an x86 gateway, and all an x86 gateway is a server running some NSX software that you can put multiple NIC cards in, so I can connect a physical workload directly, or I can connect an entire VLAN, an entire VLAN of physical or virtual workloads. And basically what the gateway is doing is putting a header on the packet when it comes into the logical network and taking a header off the packet as they go on. It's a layer 2 bridge, right? So now when you listen to like Tribune Media say, I moved 141 applications into the infrastructure over 5 months, got 9 help desk calls, what he did is connect the VLAN-based application environment through a gateway, do vMotion, move it over into the logical network, it's running, same address space, same everything. Another use case that uses this is a lot of people are doing a data center move, for instance. So what's the biggest pain in the butt of a data center move? Changing all the IP addresses, especially if you have workloads or applications who have hard-coded IP addresses, because now you're doing regression tests and all kinds of stuff, right? With NSX, you go to the new data center, you spin up a logical network, you use the same address space as the VLAN that's running in the old data center, you connect it through a gateway, you move that stuff over, and in a weekend, you've moved everything over into the new data center. So it's a big difference in terms of what happens. The other way that we do this is through our top-of-rack switch integrations. So this is Arista, Brocade, Cumulus, Dell, HP, Juniper. All of these guys have done the OVS DB integration that makes it so that now the controller can map a physical port to a virtual network. So now if there's a physical machine connected to that port, it's L2 adjacent to that logical network. If you have a VLAN, it does the same thing. Oh, by the way, I forgot one other C in there, but you'll have to ask them about their integration, whether they have it. Okay, so a lot of you will look like this in terms of your infrastructure. Typical 3-tier Cisco Nexus 7000 type infrastructure. If you've got 2 VMs running on a blade and they need to route between each other, we talked about this earlier, right? The packets flow up across the oversubscribed core and come back down. With NSX, we offload that capability. We move that into the hypervisor. Even if you're between that far right column, if you're in 2 different blades, I'm only going to use the aggregation portion of the network for those packets to flow between the VMs, because I'm doing the routing in the hypervisor. Now, one of the things that this does is it actually allows you to extend the life of this infrastructure. Because one of the things that you're seeing is a lot more east-west traffic, and as you get more east-west traffic and that traffic's having to route across the core, you're having to invest in more capacity in the core. Now, what most of the customers we're talking to want to do is move to a leaf spine architecture. Let's say the Cisco 9000 architecture, right? So the last thing you want to do is actually invest a lot more money in the core of the architecture you want to move away from. So what we do is we offload that capability, and you can bank the money that you would have spent on that other 7,000 and spend it on your 9,000 infrastructure as you move to a leaf spine architecture, as you depreciate your 7,000 infrastructure. And now this picture is exactly the same picture, right? Except for now the firewall's there. So in order to do controls down to each one of the virtual interfaces, I'm having to route that traffic out to a firewall. Now some of you may have put that on the aggregation portion, but most of it sitting in the core as well. So again, you're going and you're putting traffic and capacity across the core. we offload that down to the virtual interface, so we're doing the firewalling at the virtual interface. And this becomes the basis for the microsegmentation use case. So let me talk about that a little bit. All of you are doing a good job of perimeter defense. You have your checkpoint firewalls, your Palo Alto Networks firewalls, whatever you have on the perimeter that's looking at your north-southbound traffic. Most of you are not doing a very good job at all of controls inside the perimeter. And you're like everybody else. Nobody's doing anything inside the perimeter because it's become operationally infeasible to do things inside the perimeter for all this east-west traffic. Now, if you look at all the attacks that we've all read about, Target and Home Depot and Sony and the US government, everybody, what happens there is the threat gets inside the perimeter. Once it's inside the perimeter, it can move from server to server to server fairly freely because there are no controls inside the perimeter, right? So then it starts pumping out data, and that's pretty easy to make happen. And this is what's common to every single one of the attacks. Every one of the attacks is different from a hacker code standpoint, but every one of them takes advantage of this capability inside everybody's data center. Now, from a security perspective, security guys have loved for a long time wanted to do a zero trust infrastructure, essentially create this honeycomb effect so when the threat gets in, it gets contained to a very specific part of the data center. But even today, people who have tried to do this, that can still be dozens or hundreds of servers in that particular segment, right? And it becomes operationally infeasible as you see increased traffic to actually try to do that further down, especially all the way down to the virtual interface. And the reason it becomes operationally infeasible is because the packet's leaving this VM, it's going across the network, and it's being evaluated and enforced at the firewall, which means when I provision that VM, I had to create the rule and put it in the firewall, right? And if that VM ever moves, I have to update the firewall in many cases. And if I delete the VM, I should be updating the firewall. But you guys all know what happens then, right? Should we delete that firewall rule? No. Why not? Because my phone might ring, right? So they'll leave the rule in there, right? And then what happens is a few months later, a VM spins up, it's got the same IP address, and now it's blocking. Everybody's going, why doesn't this application work? Everybody's troubleshooting just to find this rule that was left in the firewall. Or worse, it's allowing access to something that it should be allowing access to, and nobody's phone rings on that because nobody knows that it's happening, right? So this is the problem that we all live with today. How do we fix that problem with NSX? We make it so that when you provision the VM, you're provisioning the firewall policy with it, right? So now the packet leaves the VM. Whoops, wow, jumped through a bunch of them there. Now it leaves the VM and it gets enforced right there at the virtual interface. So if this VM ever moves, all of those rules move with it. Completely automated, no human interaction at all. You can't mess this up, right? And if you delete the VM, the rules are gone for that VM. And you could have a unique set of rules for every single VM. You likely don't because you'll define, okay, app tier workloads get this, and PCI workloads get this, right? But you have the ability to be unique for every single one of them. Now, one of the things that we do is we kind of move away from the notion of applying this to an IP address, right? That's kind of old school way of doing it. So we can define custom groups here. Group things based on an operating system or a machine name or a regulatory requirement or an app tier, whatever it might be, I can define that name. And so now I can say, I'm going to deploy something that is it's a production workload on the database tier, and it has customer and PCI data on it. And I've defined what that means. And I don't know what its IP address is at all. It could be anywhere. But because it has those characteristics, it's going to have a security policy applied to it. And if I decide to change the policy for a regulatory requirement like PCI, I decide I want to add something else to that policy, I change it centrally, and anything that has the policy gets updated, right? So for example, using VDI as an example where I might have some workloads that are running, let's say, an older operating system like Windows 2003, and I don't want things that have a Windows 2003 running to be able to access a lot of the things in the data center. Maybe I'll allow them to get to email. So I'll create an unsupported OS group. So if I see a workload that spins up that has context, meaning I know it's got a Windows 2003 operating system, well then I'm going to create a DMZ around it that only allows it to get to the things that I want a 2003 operating system to be able to get to. Anything that has a more advanced operating system, I'll let get to other things. So what we've done is essentially turned that policy, the human readable policy that most guys look at and say, okay, I'm spinning up this kind of workload. What's the policy for that kind of workload? Okay, I need to create a firewall rule that meets that policy and do all this. And there's a lot of human interpretation and stuff like that here. Where what we'd allow you to do is essentially create that policy as a machine-readable document. So you've defined what it means to be in the policy for a development workload or a test workload or a production workload and so forth. So when I say I'm going to do a production workload, database tier, application type, customer data, and PCI data, now when I deploy that, it builds the rule set right then and applies it to that VM, and now it's tied to that VM wherever it moves. And this feeds a log file so I can get the allows, denies, redirects, everything that you're used to getting from a firewall log, and that can be consumed by your audit tools. So the same audit tools that you use today can be applied to these. So for instance, in a PCI audit, one of the things that happens for a PCI audit is you have a firewall that creates a segment. In an audit, you have to audit all of the workloads that are in the segment that firewall is protecting. But once you move that segment, that micro segment, all the way down to the virtual interface, now you only have to audit the workloads that actually have PCI data on them. Because that's what the segment is. It's as small as that workload. So one thing I want to make clear is I'm not talking about replacing the north-southbound physical firewall, right? That's going to stay in place. It's going to be managed exactly the same. I'm also not talking about a virtual firewall. I mentioned that before, but I want to make sure everybody understands that. I'm not talking about putting virtual firewalls all over the place because basically you move from a physical firewall doing 100 gigabits per second to a virtual firewall doing 1 gigabit per second, and you don't change the operational model at all. You're still having to update all the firewall rules and so forth. What I'm talking about is distributed firewalling, the verb, that actually is now in the platform, part of the networking platform, right? So now I get that automated policy and management as things move around. I get distributed enforcement down to every virtual interface. I get kernel-based performance, so 20 gigabits per second per hypervisor that scales out. So as I scale out my application environment, I'm scaling out my security environment. I'm not waiting and saying, okay, I'm overloading a firewall, I need to go buy another firewall, and I'm overloading that one, I need to buy another one. It's part of the infrastructure. So I get a lot of questions, my clicker's not there, about how that affects the performance of the hypervisor. If now the hypervisor is doing all of this, firewalling and stuff in it, what does that do? Well, a vSphere firewall or vSphere hypervisor pushes about 20 gigabits per second of packets without any filtering, just the vSwitch running itself. When I turn on filtering, when I'm doing filtering, I'm getting about 19.7 gigabits per second. So very little impact to the actual ability to move packets because essentially the infrastructure to move the packets is already there. I'm just doing a little bit of filtering in there. And I don't have to do the same kind of filtering that a big firewall is doing. Remember, I'm not looking at all the traffic that's coming off the network and going out of the data center, for instance. I'm only looking at the rule set that's applied to the VMs that are running on that hypervisor. and I can do 80,000 connections per second. I think, there we go, 80,000 connections per second, right? With 100 rules applied. And you could compare that to a typical virtual appliance that's doing about 6,000 connections per second. So you can see as I scale this out, I've got a huge capacity in terms of firewalling now inside the perimeter. So going back to network virtualization, this ability to create completely isolated application environments, right? This is the first step in securing an application environments. Second step is I can do explicit allow. So our firewalling capability is basic firewalling capability. Source, destination, port, protocol type stuff, right? Not deep packet inspection. And you need that kind of deep packet inspection on the perimeter because you're allowing HTTP port 80 and so forth going in and out, and you need to know what's in that. So you got to dig a little bit deeper. But inside the perimeter, you know that your app server should be talking to your data center, your database server on this port and protocol, and that's it. Nothing else should be going on there. So you can do explicit allow, and you can say app tier devices should be talking to database tier devices on this port and protocol. And you could eliminate the communication between the app tier devices because they shouldn't be talking to each other at all. They're only talking to the database and to the web tier workloads, right? So now you can actually make it so that you eliminate the path that that threat would take to move around the data center. But if you want to do deep packet inspection, this is where our partners come into play, right? So people like Palo Alto Networks and Checkpoint and Trend Micro and Intel Security, McAfee, all of these guys have done integration into the NSX platform so that you can apply their advanced services, their next generation firewall and IPS, all the way down to the virtual interface as well, right? So the way that works, and I'll use Palo Alto Networks as an example, but all of these work the same, right, is basically the management console registers with NSX that then pushes down the VM series of their product onto each one of the hypervisors. So this is a virtual firewall. You go from, let's say, Palo Alto Networks physical firewall doing 120 gigabits per second. Now you move to 1.2 gigabits per second in the virtual firewall. And so that wouldn't be enough if I was trying to look at all this east-west traffic. But when now I make that available on every hypervisor, and now when I create the policy, I can actually define the policy in Panorama, and then it gets mapped with our firewall so that it's right here. So the policy says, for that VM, I want to do deep packet inspection. So now when the packet leaves that VM, the policy steers it into the Palo Alto Networks VM, or into the Checkpoint VM, or into the Trend Micro VM running there so that I can do those advanced feature sets and let them move. And the integration is such that when I define a security group, right, like I say these are for app tier workloads, I share that name so that now in Panorama, in the management console, that group shows up so I can define what the advanced feature set is, and it gets applied here and distributed. Even if that VM moves mid-session, it's going to do vMotion and go over there, and then it'll start moving the packets into the VM on the other side, right? So very powerful integrations from all of our partners, and I encourage you to go check them out. They're all demoing this capability in their booths. So when I combine the performance with the automation and all of this stuff, I have an operationally feasible way now to do microsegmentation down to the virtual interface all over inside the data center. Very powerful capability. So in the end, what you get is the ability to create these isolated application environments, apply stateful firewalling capability down to every virtual port that moves around the data center with those VMs, put advanced feature sets wherever I think that's necessary, and then deploy those anywhere in the data center, right? Across multiple subnets availability zones, even between data centers. And I could even have, for instance, my web tier and my database tier running on the same hypervisor, but not even able to talk to each other. have the application portion running somewhere else in the data center and looking like it's clustered together in the same pod. And if anything ever moves, nothing changes because all the security, all of the networking, everything that's associated with that VM and its logical construct moves with it, right? So this is the power of NSX, and there are a lot of use cases. I talked about microsegmentation, but then you can apply that microsegmentation to VDI workloads. You can apply it to mobile devices. So, for instance, with our AirWatch product for mobile, it used to be you would have a VPN connection from a mobile, and basically everything on the phone could have access to anything on the other side of the VPN, right? Now we can say, map this application to those specific resources in the data center, and this application to other resources in the data center, and not vice versa. So you can actually get down to fine-tuning how that works, right? We see people moving very quickly into developer cloud a lot of times. After they've done IT automating IT, they go a little bit to self-service or DevOps, where they're using the APIs and spinning up their own environments for dev and test. Multi-tenant infrastructure is very big for a lot of service providers and for larger enterprises who have groups that need to be completely isolated, but you might need overlapping IP addresses and things like that. Disaster recovery we showed real quickly there for an active-passive, but you can use NSX across an IP connection and a Metro Ethernet, for instance, and do active-active data centers. Stretched layer 2 without having to do OTV and all of the things that you normally would have to do. So you could have things running in multiple data centers looking like they're running in a single data center. And then, of course, hybrid cloud networking as we move to things like vCloud Air, and if you saw Martine's keynote this morning, you saw some tech preview for some capabilities that'll come in the next year or so, where we can basically spin up a workload in any cloud anywhere and have it connected into a logical infrastructure that's running in your own data center. Pretty darn cool stuff, right? So I encourage you to take a look at it. Go take a look at all the partners. I mentioned a few of them earlier, but all of these guys are integrating into the NSX platform, right? Being able to take advantage of the distribution and the platform, the capabilities there to do some really unique things that you've never been able to do before. So let's see. I think that, one more video here from a customer, and then just to keep you here, I've got a whole box of NSX t-shirts. Really cool looking t-shirts, virtualize your network and so forth, up here, so the people who were willing to sit up front will probably get to them quickest. I don't know how many I have exactly, but don't run over everybody. Also, I want to really encourage you to fill out the form, what you thought of the presentation, the content, what you thought of me. I'm in competition with some of my, co-workers. My goal is usually I get about 20% of the audience to fill that out. Let's see if we can get that to 50%, just so that, at least fill it out. I don't even care if you say something bad about me, but just fill it out, okay? All right, here we go.
Exastar serves the identity and access management verticals for aerospace and defense and life sciences, and we also do secure collaboration and supply chain in the cloud for our customers. For Exastar, NSX has been strategic in a number of different ways. Primarily, it allows us to have a lot of control, a zero trust model at the network layer. Network virtualization for us is kind of the holy grail in terms of having a portable workload that we can move from one data center to another and do it in a secure model. And that has been something that we have not been able to do until we have come across NSX.
We've seen VMware take a great interest in evolving the product. I think even today, probably beyond what other competitors can do.
Prior to NSX, we, like most IT companies, had a workflow that involved, physical firewalls, a lot of processes, and these would span weeks at times. And now with NSX, that goes down to hours or minutes at most, because of the automation involved, because of the virtualization in our control.
We chose NSX over the competitors such as Cisco, ACI, simply because of market adoption. NSX has gained much more momentum in the marketplace and seems to have broader acceptance by the partner ecosystems than the competitors that are coming up.
NSX has been game-changing because it has a demonstrable reduction in level of effort. So when we're reducing our time to deployment by 80%, that leads to savings that we can deploy folks on other projects.
My job is to work myself out of the job. I want to make my job so easy that I can do other things.
For Exostar and its customers, what we're seeing is for disaster recovery, the bar is getting higher and higher in terms of the data we're protecting and how fast we can bring it back online. With NSX, now what we're able to do is basically take that container, always have it in our DR facility, and when we need it, we can basically, at a push of a button, bring it online and bring our customers back online.
So my advice in getting NSX deployed in your environment is to start from the bottom up. To start with your regular network administrators, your regular sysadmins. It doesn't have to come from management. Once you start to see the visibility that you get, you'll never miss the command line.
All right, one last slide. We've got a lot of professional services, a lot of people that are out there that can help you do this. So I encourage you, you can start small. NSX is not one of those things that you have to decide, I'm re-architecting my data center and ripping everything out. This is something that you can put on 4, 5, 10 hypervisors, see what you can do, start showing others, bring in the security guys, bring in the networking guys, let them see what they can do. And this is what a lot of customers do, and you move very quickly to doing some pretty cool things. So thank you very much for your time. Fill out your forms, come grab a t-shirt.